To begin Unit 9, we are going to look at a few more identities that are similar to the ones that we saw in Unit 8 and can still be found in Section 5.5 in your textbook. These are going to be the product to sum and sum to product identities. So let's look at the first ones here. So the first ones, these are our product to sum formulas. These are found on page 385 in your textbook, so you can reference them there as well. As you can see on the left-hand side, these all start out as products of either sine times sine or cosine times cosine or sine times cosine, where u and v are just angle measures again. These products are then turned into either differences, as you can see in the first one and the last one, or sums, as you can see in the second and third one. So what we're going to do is we're going to use these formulas to change products into sum or differences. And that's what we're going to do here first. As I go throughout the examples, I will be referencing these 4 formulas. So you may want to write them down somewhere or look at them in your textbook as I go through the examples. Let's look at the first one. So the first example is we are going to take this cosine of 5x times sine of 4x. We're going to use a product to sum identity or formula to rewrite this as a sum or difference. So if I take cosine 5x times sine 4x, okay, 5x acts as u, 4x acts as v, and we are going to substitute it. And since this is cosine times sine, I'm substituting it into the 4th identity that we saw on that previous page. So I'm going to just substitute that 1/2 bracket or parentheses sine, and u was 5x plus v 4x minus sine 5x minus 4x. And now I'm just going to simplify what I can to turn this into the simplest form. So 1/2, I can go ahead and add the 5x and the 4x to get 9x and subtract the 5x and the 4x to just get x. And at this point, you can distribute the 1/2. You don't have to. And nothing else simplifies, so I'm just going to leave it like that. So all you did was rewrite this into in this case, a difference. So you wrote the product into a difference. Okay, let's look at another one. So in this one, again, we are going to rewrite this product as a sum or difference. This time we have a number out in front. Not going to change it too much. So I have 10 sine 5 theta times sine 3 theta. Okay, 5 theta is going to be my u, 3 theta is going to be v. And when I rewrite this one, we're just going to keep the 10 out in front for now. Okay, and I'm going to substitute my identity for this part. And in this case, I'm going to be looking at the first identity. So the first identity looks like this. We have a 1/2. And then cosine 5 theta minus 3 theta. So u minus v minus cosine 5 theta plus 3 theta. Okay, and again, I'm just going to simplify it. So when I simplify this, this 10 can multiply by this 1/2, leaving me with 5 out in front. And then cosine 5 theta minus 3 theta is 2 theta. And minus cosine 5 theta plus 3 theta is 8 theta. And again, you can distribute the 5. You don't have to. I'm going to leave it factored. This is going to be my final answer. Something that I want to point out is you want to make sure if you have more than just theta, like we have 2 theta here, we have 8 theta here, you want to make sure you put parentheses around that. It's a good habit to get into because I know WebAssign, especially when you're entering something like this, they're going to want parentheses around that 2 theta or 2x or whatever your variable is there. Okay, let's continue on. Maybe. Okay, there we go. So now let's look at the sum to product formula. So these are found further down the page on page 385 in your textbook. These are going backwards. So now you're starting with a sum or a difference, excuse me, on the left-hand side and changing this into a product. Okay, U and V are still just angles. We're going to look at a little bit more application problems with this as we go through the example. So again, I'll be referencing looking at like the first, the second, the third, or the fourth. So get those, write those down, or have those handy as we go through the examples. So first one, we're going to rewrite sine of 3 theta plus sine of theta. We are going to write this sum as a product now. For this one, we are going to be using the first formula of those 4 that I gave you when we rewrite this. So that first identity looks like this: 2 sine, so 3 theta is U, theta is V, 2 sine 3 theta plus theta over 2, and then cosine 3 theta minus theta over 2. Okay? So then I get 2 sine 4 theta over 2. So I'm just adding and I'm going to subtract cosine 2 theta over 2. Further simplifying 2 sine 2 theta, so 4 theta divided by 2 is 2 theta. Cosine 2 theta divided by 2 will just be theta. And so that's how you would rewrite that sum as a product. Let's do another one. This time we're going to rewrite this difference, cosine of 6x minus cosine of 2x, as a product. This will be using the 4th one of that list. So it'll look like this. This is the only one in of those identities that start with a -2. So it's going to be -2 sine of 6x plus 2x divided by 2, and sine of 6x minus 2x divided by 2. So then we get -2 sine 6x plus 2x is 8x divided by 2. 6x minus 2x, 4x divided by 2. Continuing to simplify, sine of 4x times sine of 2x. And that would be my final answer there. Okay? Now let's actually try it with some numbers. So how can these sum to product formulas actually help me find the exact values of some angle measures being added together? So we have cosine of 195 degrees plus cosine of 105 degrees. We are going to first convert this into a product and then actually evaluate it because what we'll see then is that we end up with some values that are on our unit circle, and we can find the exact value then of this sum. So let's start by changing it using my identity to a product. So 195 is acting as U, 105 is acting as V. This one is using the third identity on that list. We have 2 cosine of 195 plus 105 divided by 2, and then cosine of 195 minus 105 divided by 2. Okay, so then 195 plus 105, that's going to be 300 divided by 2. And then cosine of 90 divided by 2. We're going to continue to simplify this. So 2 cosine, 300 divided by 2 is 150. 90 divided by 2 is 45. These are both values that are found on my unit circle. And let's just substitute in what we know. So on our unit circle, cosine of 150 is negative square root of 3 over 2. And cosine of 45 is square root of 2 over 2. And now I'm just going to multiply all these values together to get this exact value. So these two can simplify out. Negative square root of 3 times square root of 2 is negative square root of 6. All over 2 times 1 is 2. And that would be the exact value of that sum. Okay, let's finish up with one last one. So we're going to change this difference into a product and again find the exact value. This is going to be using the second formula. So sine 5 pi over 4 minus sine 3 pi over 4. This is U, this is V. So I end up with 2 cosine 5 pi over 4 plus 3 pi over 4, all divided by 2, times sine 5 pi over 4 minus 3 pi over 4, all divided by 2. And now I just need to simplify. So I get 2 cosine. That would give me 8 pi over 4 in the numerator, divided by 2, sine 2 pi over 4 divided by 2. Continuing to simplify. So 8 pi over 4 is the same as 2 pi over 2. 2 pi over 4 is the same as pi over 2, still divided by 2. And so that will simplify to 2 cosine of pi and sine of pi over 4. So pi over 2 divided by 2 is pi over 4. And now let's substitute our values. So 2 cosine of pi is negative 1 on our unit circle. Sine of pi over 4, square root of 2 over 2. If I multiply all this out, these 2's will simplify. Negative 1 times square root of 2 is negative square root of 2. And that is it for sum to product and product to sum identities.